Hello guys, welcome back to Maths on African Motives, still on our mathematics N5 revisions, also learning from our basics. In this platform, we shall be talking about introduction to the integration by parts, whereby you are supposed to be knowing your basics integrals. This case, wondering whereby you be given integrals of x times the cosine of x with respect to x, and you'll be wondering, how am I supposed to integrate a condition whereby I am multiplying two terms or that are different? Maybe you're talking about algebraic versus a trigonometric. We are talking about a trigonometric versus an exponential. We are talking about an algebraic versus an exponential function being multiplied together. If we're talking about derivatives there, we know that the derivative with respect to x of maybe we've got x times the cosine of x. If we are dealing with the derivatives, that is where we talk about the product rule in this case. But in integration, we do not have the product rule. We are going to apply what is referred to as the integration by parts. So how do you apply the integration by parts? That is the most important part. So we are given the formula that we are going to apply from our formula sheet, which states that the integral of f of x by g prime x with respect to x is equivalent to f of x by gx in this case, minus the integral of f prime x gx with respect to x. So I'm going to explain this formula that we are given, which can be given in short as the integral of u. First derivative of v is equal to uv minus the integral of v, the first derivative of u, or the first derivative of u times v in this case. All right, that's one and the same thing. What exactly are we talking about here? Remember, we said we've got the product of two terms in this case. The first part is going to be the f of x. It's not like in the order that you're given. What you need is to know that this f of x is supposed to give us a derivative. We are supposed to find its derivative in this case from the f of x. So it's a function that we can be able to differentiate it. If we can be able to differentiate that function direct, then we can choose that function to be our f of x. Normally, it's best to choose an algebraic expression. Yes, we can choose a linear and exponential as long we can be able to differentiate that part. Then if we move on to this part of g prime x dx, is the part that we are supposed to integrate in order for us to obtain gx, in order for us to obtain this gx. It's the part that we are supposed to be integrating. So meaning to say, from f of x, we are supposed to find its derivative. From this g prime x, the part that is remaining of g prime x dx, we are supposed to find its integral. By finding the integral of this, we are going to obtain gx. In this case, this is the gx that we are seeing on this part. So meaning to say, the part that is remaining must be integrated. So it's a part that you can integrate. F of x, it's a part that you can find its derivative. As long you can do that, then you are going to apply your formula. From this formula, you can simplify as far as you can. So I'm not gonna remove this formula. I want us to use this formula to integrate some of the integrals that we have. Like I said, we can use the second one that we have, but this is the one that you're given in your formula sheet. So I'm going to explain with this one so that we can just understand our basics and we choose which one is the best. Let's say, like for the example that I gave us in the previous case, we are given to integrate x cos of x with respect to x like this. It's a product of two functions, an algebraic and a trigonometric function in this case. So in this case, we can choose f of x to be cosine of x. We can differentiate cos. We can integrate x. So any part we can choose it to be our f of x or to be the g prime x. So in this case, we can choose just to be x to be our f of x. It's best when you're dealing this part to choose what? An algebraic expression. But any part can work actually in this case. All right. So if we had to choose in this case f of x to be x. Also, the other thing that you're supposed to consider is when you substitute back, are you going to be able to integrate? You can choose your trigonometric, but when you substitute back, you find out you are having another difficult integration inside. So that is another thing to avoid. So that's the best. We choose out our f of x to be x. The first derivative, as we can see, we need its first derivative here. So we are going to find the first derivative with respect to x, which is going to give us a 1. All right, from the same part that is remaining, this part of x, of cos of x dx, this is our g prime x dx. So meaning to say, in this case, we are going to have g prime x, all right, sorry, let's just take it as it is. This is our g prime, which is the cos x. So meaning to say, this is the part that we are going to remain with. This is the part that we are going. Sorry for that. This is the part that we are going to refer as our g prime x dx, meaning the cos of what? The cos of x, all right? So we are saying the g prime, sorry, this is the g prime here, the g prime of x with respect to x is equivalent to the integral of the cos x with respect to x. Actually, in the first sense, you're not even supposed to put this integral, this one. You're not supposed to put this in the first place. You're just supposed to write your g prime, okay? This part here is equal to the cos of x, this g prime dx, but we are supposed to integrate now to obtain what? To obtain the gx. Remember what I explained, that the integral of g prime x gives us this gx. So meaning to say, at the end, we are obtaining our gx in this case, which is the integral of cos of x, and the integral of cos, we know that this is a sine. We are now back to our integrals, all right? So having our gx and having our f prime x, we are now going to substitute back into the formula that we are given here. So we are saying the integral of x cos of x in this case with respect to x is going to be equal to f of x. We got our f of x, we said it's x times gx, which is the first derivative, which is the integral of cos x, the one that we got here. So we're going to multiply to the sine of x in this case, minus, we have the integral of, so we're going to have the integral of f prime x. So our f prime x in this case, that is the first derivative of our f of x, which gave us a 1 times gx dx. So our gx in this case, that is the sine of x, but multiplied or integrated with respect to x. We are going to integrate this part with respect to x. So this is the formula that you have given on your formula sheet. So what you simply need now is to simplify further. So from this part, we are going to have x, the sine of x minus, now let us take note on this part. We are supposed to multiply 1 times the sine of x, which is simply the sine of x in this case. So this is just the sine of x with respect to x. So meaning we are supposed to integrate now this part that we are given. We are supposed to integrate the sine of x with respect to x. So remember, from our integral, sine is taken from negative cos in our on our integration, on our derivatives. Remember, when you differentiated cos, it gave us a negative sign. So if you integrate a sign, it gives us a negative cos. Remember, it's a reverse of what? The derivative. So you're going to have negative, which is already this negative that we see here, but the integral of a sign itself, this one, it gives us a negative cos. So we are going to have a negative cos of x like this, plus the constant of integration. On the first part here, there's no need for us to write the constant of integration because we are going to substitute this later on. So that means in this case, we can simplify further. Where am I getting this cos here? This is a sine. All right, so I think someone was even wondering, this is a sine here. So we've got x sine x, sorry for that. So we're gonna have x sine of x, negative and negative is going to be a positive. So you're going to have positive cos x plus constant of integration in this case. So that was the whole part that we're going to have at the end. So note that we are dealing with the product in this case. F of x be the function, the algebraic part, the g prime x dx, the part that you can integrate, let it be the trigonometric function. such that here, because if we are to integrate x, remember it is going to give us x squared over 2. If you are to differentiate cos, it is going to give us negative sine x. So whatever that you are going to integrate at the end is going to be complicated because you are going to be working with x again and another x. So that is why it is best for us to take our f of x to be an algebraic expression and the g prime x to be a trigonometric function in this case. All right, so that was the first part. Still, like I said, from our formula, let us try to have another question that we can consider still using the same part, or even here we could just use this other formula that I explained there, but it's just one and the same thing. I just hope we understand that one. It's like this. It was given as, remember I said we can write this as integral of u of v prime in this case is equivalent to uv minus the integral of v u prime, whereby in this case we are simply saying u is just original function that you're given, just like f of x. So in this case, that's our u is being our f of x. So if we are to use this formula, we are simply saying our u in this case is f of x, which was cos. Remember that was cos. Our formula was x cos of x dx. So meaning to say, if we take the u to be x in this case, what are you going to need? We are going to need the first derivative of u in this case with respect to x, in this case with respect to x, which is going to be a 1. Then from the v prime that we have in this case, we've got v prime, which is in this case, the part that is remaining of cos x in this case with respect to x. So what you're going to need in this case is definitely to integrate what is the what was the function that was there before we differentiated this, that is the integral of cos x, which is going to be a negative sine x. So as you can see, it's just one of the same. We substitute just like the previous part, you integrate with respect to x, whatever that you're going to have. So I think we can just choose which one is best of these. Let us check another part of this part, which is ln. Another part, they can ask us to integrate the ln of x, and you wonder to say, how am I going to apply by parts just given a single term, ln of x? So in our normal sense, we understand that if I write x is same as 1x, if I just write y same as 1 times y in this case. So if you are given the ln of x, this is not different from the same condition that we're talking about here. It's the same as we are multiplying 1 times the ln of x. This is just one and the same thing. And we understand that 1 times the ln 1 times the ln of x is same as ln x, whereby this is a function. It's actually a term. With respect to x, it's like we've got 1x to the exponent of 0. So it's a function having that as a 1. So meaning to say we've got two terms that are now multiplying each other. And when dealing with a ln, it's best for you to have your f of x as the ln. Why? Because if we choose to say our f of x is a 1, let us see what was going to happen. If we said f of x is 1, its derivative in this case was going to give us a 0 because it's a constant. So this part was not going to work. So it's best now for us to have our f of x as the ln of x. Can we differentiate the ln of x? Yes, we can. Remember, the derivative of ln x is 1 over x from the first derivative of x over f of x. Then now we take the one that is remaining with the dx. This is our g prime x, this one. F of x, it's ln x, then the part that is remaining, that is our g prime x dx, which I said it is equal to what is remaining. If you take this ln, what are you remaining? We are remaining with 1 and dx. So meaning to say 1 dx. We integrate both sides so that we obtain gx from that. G prime x, we have gx, which is the integral of 1, of which we know that we can determine the integral of 1 with respect to x. It is going to give us what? It's x. That's the integral of a constant with respect to x, is that constant times x, which is 1 times x, which is what? Which is x. Once we have this part, guys, we are done. Once we have this part that we are seeing here, we are going back to our formula to substitute whatever that we are given into our ln. So we are simply saying this part, the whole of this ln is going to give us the ln of x dx is going to give us f of x by gx in this case, whereby our f of x, that's the ln of x. So we're going to have the ln of x times gx, which is our gx. In this case, it's x. So we're going to have this multiplied to x minus the integral of f prime x. Remember, we got the derivative here, f prime x, which gave us 1 over x. So this is going to be 1 over x times gx, our gx, which is x in this case, dx. So that's it. We have applied the formula. Once this formula is applied, it's now you and your question now, how to simplify from this part. How are you going to be able to simplify? So they just multiply ln of x times x is going to give us x ln x. Never be tempted to multiply ln of x and x, to multiply these two. They are not common in this case. So you cannot multiply this, but this can multiply the number that is on this part, which is a 1. So you can multiply that. All right, that is going to be minus the integral of, simplify what is inside of the integral. This is same as over 1. So this and this can cancel, meaning to say we are going to remain with the 1 over 1, which is just 1 with respect to x. So we are going to integrate 1, just like what we did here. We integrated 1 with respect to x, and we got x. So meaning to say we are going to have x ln of x minus the integral of 1 with respect to x, which is going to be x plus the constant of our integration. So that is the whole idea, how you integrate your ln x in this case. So you just want to have another example that has got a ln, but now having a normal algebraic expression, not just ln like what we have, but they can ask this part just like ln of x, integrate the ln of x. Then you'll be wondering, what exactly am I supposed to do? So from this formula, let us say our question was to integrate or to simplify the integral of x to the exponent of 4 ln of x with respect to x in this case. All right, so when dealing with the ln, remember, let's say you want to integrate the ln of x, it's going to be difficult. So it's best for us to choose that ln to be our f of x, because we can differentiate it. So it's best for us always when dealing with the ln. F of x is equal to the ln of x. We find its derivative. The derivative of ln is going to give us 1 over x. Then the rest that is remaining, we are now putting it back to say, if this is f of x, then the rest is g prime x dx. So meaning to say our g prime x dx in this case is the part that is remaining. We took this ln x, take note, this is the part that we just took here. From the whole of the integral, we took this f of x. So we are remaining with the g prime x. What is remaining? We are remaining with x to the exponent of 4 and what? And dx. So this is the one that is representing g prime x dx. So like I was saying, the order does not matter. What matters is what you have taken to be your f of x. What remains becomes your g prime x. What matters is what you have taken in the first place. If you want to matter about the order, therefore rearrange. You have to rearrange. If you are confused about the order, you have to rearrange in a way that you understand. From this part, we can integrate both sides so that we obtain the value or the expression for gx. So for gx is going to be, remember, integral, we add 1. There we are going to have x to the exponent of 5. We divide by that new exponent, which is 5. We divide by 5. All right. So here there's no need for us to even write our constant of integration. So now we are back to this integral that we are given. So we are simply saying at the end, the integral of x to the exponent of 4 ln of x with respect to x, in this case, is going to give us what? F of x, which is the ln of x in this case. So we are going to have the ln of x as our f of x multiplied to gx, which is our gx in this case. That's x to the exponent of 5 over 5 in this case, minus, we are now into the integral of f prime x. We're going to have the integral of f prime x, which is our f prime x in this case. That is 1 over x times gx, our gx, that is x to the exponent of 5 over 5 dx with respect to x, whatever that you're going to have. So the formula is applied. We have applied our formula. We have substituted into the formula. All we need now is to simplify further. So the ln of x times x to the exponent of 5 over 5 is simply x to the exponent of 5 over 5 times the ln of x, minus, in this case, we're going to simplify this. This is you're multiplying. So we've got x here into these ones. They are 5. So you're going to remain with the 4 of them. So you're going to remain with 4 of them in this case. So you can even take the 1 over 5 outside of the integral. So that does not affect us. So we can take this 1 over 5 out of the integral. So we remain with the integral of what we can properly see. We are left with x to the exponent of 4 inside. So we're going to have x to the exponent of 4 with respect to x. And this we can be able to integrate. That is the whole idea of this part, that, okay, here we can integrate our integral properly. X to the exponent of 4 is the same part that we had here. X, it gave us x to the exponent of 5 over 5. So we integrated this before. So we are going to have at the end, combine everything, x to the exponent of 5 over 5, the ln of x minus, here we've got 1 over 5 multiplied to the integral of x to the exponent of 4, which we integrated before here, and it gave us x to the exponent of 5 over 5. So that's it, plus the constant of integration. So you can just simplify x to the exponent of 5 over 5, the ln of x minus, here we can multiply 1 times 1. This is same as 1. So you're going to have 1 over 5 times 5, which is going to be 25, x to the exponent of 5 plus constant of integration. So that was the whole idea of our question in this case, meaning to say the integral of this whole part that we see here is going to give us this part at the end. This is what we're going to have at the end from our by parts concept. So that is how we can be able to apply our by parts. As you can see, guys, it's all on the formula. The formula, the understanding of the formula is the most important part that you need in this case. So we're going to try another question again and see how we are supposed to have these integrals. Let us just check another part where we can maybe integrate 2 times or so forth, so that we can be able to work with question papers now. So just have to try work with more question papers, but I think we have a lot of question papers that we have done on integration, and I've been explaining this, but now it's just like separate thing. Yes, we have a condition whereby we can be able to integrate more than once. All right, we remember that part. We're just applying our by parts once. We can have a condition whereby we can apply our by parts, especially we're dealing with the trig algebraic function raised to a certain exponent and an exponential or a trig function. The exponent here that is going to affect your x. This one does not work on ln, because on ln we choose ln to be our f of x, which we are choosing ln. We're having that condition, x to the exponent of 4 ln of x. So don't confuse what I'm trying to say here with this part. We're having x to the exponent of 4. But here I'm saying we are supposed to integrate 2 times, because you are choosing your f of x to be x to the exponent of 2. Your integral by parts is going to be applied 2 times. But on this part, we chose ln, not this. If we were to choose this on a normal condition, if it was going to work, it means we're going to integrate 4 times. We're going to apply our integration 4 times. All right, let us see what we're trying to say in this case. Remember, said we're going to choose our u in this case, which is x to the exponent of 2. So that is our f of x. So if our f of x is x to the exponent of 2, that means we're going to have its first derivative, which is going to give us 2x. The remaining part here is going to represent our g prime x in this case. So we're going to have this g prime x. So meaning to say our g prime x dx is the remaining part, that is e to the exponent of 5x with respect to x. So integrate both sides, we are going to obtain our gx in this case. Remember the integral of e, that's e to the exponent of f of x over the first derivative. So you're going to have e to the exponent of f of x over the first derivative of that f of x. The first derivative there is going to give us a 5. So that is what you're going to have for gx. If we had to apply this method, I want us to see what was going to happen in this case. We're going to have this as equal to this whole integral f of x by gx, whereby we've got our f of x. So we've got the integral here of x squared e to the exponent of 5x dx, which is going to be f of x, which is x squared, times gx, which is e to the exponent of 5x over 5 in this case. All right, minus the integral of f prime x, which is in this case, we are having 2x by gx, whereby our gx is e to the exponent of 5x over 5 with respect to x. So this is what I'm saying here. If we were to simplify, you're going to see that at the end here, we are remaining with x and also another function of e. We are having another product again, just like what we had, x to the exponent of e to the exponent of 5x, it's a product. So meaning to say we are supposed to apply by parts again in order for us to integrate this part. But let us just simplify here, same as 1 over 5. So we're going to have 1 over 5 e to the exponent of 5x, x squared in this case, minus, or we can just start with x squared there. We can just start with x squared, no problem. That's here. We can just start writing x squared, which is one and the same thing. So we're going to have e to the exponent of 1 over 5x squared, e to the exponent of 5x, just one and the same thing to write. All right, minus here, this is same as over 1. So we can take the 2 over 1 times the 1 over 5 outside. So 2 over 1 times 1 over 5, that one is going to be 2 over 5. So we are going to take 2 from this part, 2 times 1, 1 times 5. So it's going to be 2 over 5 out of the integral, meaning to say we remain there with x and also e to the exponent of 5x that we can properly see in this case. That has to be integrated again. So by integrating this, we are supposed to apply by parts because we're talking about a product here. We have a product again, whereby we said whenever we're dealing with a product, we are going to apply our by parts concept. So meaning to say, we are supposed to choose our f of x again. We are supposed to choose our f of x just like the previous part that we had. So I'm just going to have it here. So we are going to choose our f of x. So this time we can choose our f of x to be x. We find its first derivative with respect to x, that's a 1. Then that means the remaining part is our g prime x, and the remaining part is this part of e, which is the same part that we worked, e to the exponent of 5x. So meaning to say this part is not going to change. It's just a repetition of what we did here. So meaning to say our gx at the end is going to be e to the exponent of 5x over 5. That's the advantage, that some of the parts you just see, you have already worked with them. So it's just a repetition that is happening. So in this case, we're supposed to apply this part as it is, 1 over 5. All right, this is what we're supposed to have. We integrate this part aside, or we just substitute. So what is best for you is the one that you can apply. But here what I'm simply saying is that we can even substitute 1 over 5x squared e to the exponent of 5x like this, minus 2 over 5. We now integrate this part. So to integrate this part now, that's where we go back to our by parts formula, f of x by gx, f of x, which is x in this case, by gx, which is our gx, is a to the exponent of 5x over 5 in this case. All right, minus the integral of f prime. So we're going to have the integral of f prime x, which is our f prime x there, it's a 1, times gx, whereby our gx is e to the exponent of 5x over 5 in this case. So with respect to what? With respect to x. So this is the whole part that we are going to obtain. We have applied our by parts formula in this case to integrate this. So this whole part, it's a by part concept that we are applying. From this integral here, this is what we are going to obtain. We apply it by parts again. So we can simplify further now. So that is going to be 1 over 5x squared e to the exponent of 5x minus 2 over 5. Yes, you can multiply, but you can just leave it for now because there we need to integrate again. So you're going to have this one is same as 1 over 5. So you're going to have it as 1 over 5x into e to the exponent of 5x minus, we can take out the 1 over 5 of the integral in this case. So if we take this 1 over 5 out of the integral, we are going to be left with the integral of what? E to the exponent of 5x with respect to x. And we talked about this integral. I said it's going to give us e to the exponent of 5x over 5. So the whole part here, after integrating, if we take this 1 over 5 out, then you integrate e to the exponent of 5x. You're going to obtain e to the exponent of 5x over 5. This one is just a repetition, guys, as we can see. So everything plus the constant of integration. So that's here. We are going to simplify from what we have, expand brackets. That is the only part, or you can just even just leave it at this stage, or you can just expand brackets 1 over 5 x squared e to the exponent of 5x. If we multiply this part here together, we are going to combine this part together. We are going to have minus 2 over 25. Multiply 5 by 5, that's going to be 25x e to the exponent of 5x. We do the same thing. We multiply this part together here. So, but here take note, this negative 2 is multiplying this part, and also, so we are going to multiply negative 2 times minus 1 over 5 times 1 over 5, like this, negative 2 over 5 outside of the integral, this one, outside of this bracket, times this other, because this bracket is affected also by what? Minus 1 over 5, and also affected by 1 over 5 inside, like this. So this is what you're going to obtain. So it's minus 2 times minus 1 there, which is going to be a positive. So you're going to have 2 over 5 times 5 times 5, which is going to give us 125 in this case, e to the exponent of what? E to the exponent of 5x plus the constant of integration. So take note, the number that is outside here has to affect this and also affect this term. So that is how we're supposed to have this question. So if you can see, we have managed to integrate everything. We have managed to integrate everything with respect to x. And don't forget, even whatever part of your integral that you're working with, always we are supposed to work with what? We are supposed to add the constant of integration. I think now we are used to this formula. Let us just have the last question. The integral of the ln of x. The integral of the ln of x over x with respect to x. All right, this is another condition that you might even wonder to say, what is it? Because we know that we are supposed to have this as a product. Remember, we said our formula is supposed to be the integral of f of x by g prime x dx is equal to f of x by gx minus the integral of f prime x gx dx, like this. This is what we are supposed to have on our formula. But if you take on this formula, it's not a product that we have. It's a fraction, ln of x over x. How can we make this to be a fraction? All right, this is same as we've got 1 over x in this case. All right, you can consider this as 1 over x. So instead of having this as ln x over x, we can have it as 1 over x, like this, multiplied to ln of x with respect to x. As we can see, we have got this part and this part separate. We have a product now, but it was hidden from this fraction that we see. So meaning to say, we have a ln. Again, we are back to that ln where I said whenever you are dealing with a ln, choose that ln to be your f of x. So meaning to say our f of x in this case was going to be the ln of x. We have to find its derivative. So the derivative of our f of x, which is ln, we saw that was going to give us 1 over x. Meaning to say the remaining part, which is the 1 over x and the dx, is now our g prime dx. So meaning to say our g prime x dx is going to be the remaining part, which is 1 over x dx. We integrate this both sides. So meaning to say we are going to obtain our gx in this case. So as you can see, we are dealing with 1 over x, guys. Derivatives and integration is reversed. If we differentiated a ln to give us 1 over x, it means if we integrate 1 over x, we are going to obtain what? We are going to obtain a ln in this case. That is the idea. So in this case, we are integrating 1 over x. We are going to obtain the ln of x with respect to x in this case with a constant of integration, but we don't consider that constant of integration. So now on your solution, you are now saying the integral of what you are given. This was for us to integrate in to understand what the question is all about. But the question is asking us to integrate ln of x over x. So the separation was just for us to understand our question, but when answering, answer the question that you are given. So we want to integrate this part. So the integral of ln of x over x is going to be f of x by gx. Our f of x, which is what? Which is ln of x. So this is going to be the ln of x times our f of x. As you can see, f of x is also ln x. So this one was going to, our gx, sorry, which is going to be ln x. So it's f of x by gx. Minus, in this case, f prime x. Our f prime x, in this case, we're going to have the integral of f prime x, which is 1 over x. So this one is going to give us 1 over x times our gx, which is ln x. So we're going to have ln of x with respect to x. All right. There's something that is happening here. In actual sense, we are supposed to simplify, then we integrate this and that. But if you check, there's something that is happening. Ln x and ln x, that's ln x squared. So this is ln x squared like this, which is same as ln squared x. All right. So this can be given as ln squared x minus the integral of, I want us to see what is happening on this integral here. We are going to have 1 over x times ln of x. That's 1 times ln on top, which is going to be a ln of x over x times 1, which is going to be x with respect to x. And there's nothing that we can take outside of the integral in this case, because these are variables. If we check this part that we are to integrate now and the part that we were integrating in the first place are the same. It's like we are back to the original question. This is what we have in our original question. This is the same part that we had here. The integral of ln x over x dx is equal to, we have the same thing on our answer, the one that we are integrating, and we also have it on our answer. So how do we simplify? We simply take this to the one side of the of our integral. In this case, we are going to simply take this to one side of the integral. So that one side of the equation is like an equation. You collect like terms, you combine. So remember, if we have got x plus x, we get 2x. So if we get this integral to the other side, it's going to add. So if we add the integral of a certain term plus the integral, these two terms being the same, we are just going to have two integral of that particular term. So meaning to say, the moment we take this is a 1. The moment we take is going to be a 1 plus 1, which is going to give us 2, the integral of the ln of x over x with respect to x. We have taken this to the other side, it becomes a positive there. So meaning to say, we can be able to what? Combine our terms, add together. Just like x plus x is 2x. So we are adding the same integral. So the answer is just going to be 2, the integral of that same part that we have, which is equal to, on this part, we are having ln squared x. So what are we going to do now from this ln squared x that we have? Our question was to integrate or to find the integral of ln x over x. And we have it back here. So to remain with this, we are simply going to be able to divide by 2 by 2. So the moment we are dividing by 2, we are remaining with the integral of what? We are remaining with the integral of ln x over x with respect to x by cancelling this by 2, which is equal to what? Which is equal to ln squared x over 2 plus the constant of integration, because we are done integrating. We are not going to integrate any part anymore. So we are now writing our constant of integration at the end. So this is the play around that you need. That's how you need to play with your integrals. By parts formula. The application of the by parts formula is very, very important in our syllabus, the by parts. As we are seeing now, they are even extending it further, this by parts. So you need to know the basic so that we will understand how they are they even extending that by parts, whereby they even give you a function to choose as your f of x or to choose as the hue. So be careful on that one as we are revising towards our exams. But I think that's it, guys. We'll see in our next classes. Let's just continue to revise as much question papers as we can. Prepare yourselves. Exams, once the results are out, it means exams, they are around the corner. So it means very, very soon it's us who are writing. So let's revise as much as we can. The time is not on our side, actually.